Wow, is it wet out there? You know, without an atmosphere, it would not even be raining at all. As we'll discover, the atmosphere is essential. Without it, there would be no weather. Well, welcome to the weather portion of the course, and welcome to the Epic Flight Academy. This is the Private Pilot Ground School, and my name is Mike Thompson. Well, let's start our discussion of weather by defining some common terms. We frequently throw around the words weather, climate, and meteorology. Are they the same thing? Not exactly. When we talk about weather, what we mean is the local area weather. And by local area, generally speaking, we're talking approximately a 5 nautical mile radius. Climate is slightly different in that it is larger. We talk about, for example, a tropical climate. A climate might cover several states, or the entire Caribbean might be spoken of as a tropical climate. And then finally, meteorology. Meteorology is a science. It is the study of the atmosphere around the entire planet. The atmosphere of planet Earth is a thin layer of gases. It surrounds the entire Earth. And you can see here, this is a picture from a satellite in space. That layer of gases is relatively thin, and it serves two critically important functions. Number one, it helps the Earth balance the amount of heat absorbed from the sun and the heat that escapes from the Earth. Number two, also very importantly, the atmosphere protects us from radiation. Now, in spite of that protection, some of the UV rays still penetrate, and that's what caused me to get a sunburn last weekend at the beach. Now, when we talk about the gas composition of the atmosphere, we generally talk about 80% nitrogen, 20% oxygen. That is approximately true. However, I would like for you to understand more specifically the exact amounts. Our reference for weather will be an FAA advisory circular. It is the Advisory Circular 00-6 Bravo. It's a great advisory circular. It's been around for many years, and it's called Aviation Weather. If we look in Chapter 1, we're going to find this table, Table 1-1, and we're going to see much more accurate representations of the gases in the atmosphere. We see, for example, that hydrogen is approximately 78.09%. We round it off to 79. Sometimes we round it off to 80. Oxygen, we see, is 20.947%. And again, we round that off to 21. Sometimes we round it off to 20. Okay, so take a look at the table. You can see all of the actual gases and their approximate accurate percentages. Now, the atmosphere has layers throughout it as it surrounds our planet. This graphic you're going to see in EPIC's online Schoology course. Now notice it shows us 4 layers, and notice that those layers are represented as being much thicker than they actually are in reality. They're represented thicker so that we can see them and study them. Go back to the photograph from space to see in reality how thin the atmosphere actually is compared to the whole planet. So let's take a look at these layers. How many are there? Well, in this graphic, again, where are we? Aviation Weather 006B, Chapter 1. We're showing the first layer is the troposphere. In that first layer, the vast majority of weather occurs. Then we reach the tropopause at approximately 6 to 7 miles or 13 to 15 kilometers. You see miles on the right-hand side of the chart and kilometers on the left. Well, how many feet is that? Because as pilots, we think of altimeters and we think in terms of feet. A quick conversion for you, a kilometer is 3,280 feet. So above the tropopause, we get to the stratosphere, then the mesosphere, and the thermosphere. So how many layers in the atmosphere? You got it, there's 4 layers. Now on this graphic, I'd like you to notice this yellow line. This yellow line is showing the temperature, and you can see temperature in Celsius across the bottom. Notice as we go up into the troposphere, the temperature goes down. Now our flight instructor probably told us that the average is 2 degrees per 1,000 feet, 2 degrees Celsius per 1,000 feet. But an interesting thing happens at the tropopause. As I continue higher in the stratosphere, notice the temperature actually goes up. Well, why is that? Folks, the reason for that is ozone. Ozone absorbs that harmful radiation that we mentioned earlier, and that causes the temperature to rise. Then we get out to the mesosphere, where we have very little atmosphere left, and we see the temperature again starting to drop. And then we get to the mesopause and into the thermosphere, and now we're out at altitudes where ATC might say, traffic advisory, space shuttle at 2 o'clock. Now, I don't think I'm going quite that high in my 172, but notice at these altitudes that temperature starts to go back up because now we are in the reaches of outer space with no atmosphere at all. When pilots refer to the atmosphere, we refer to a standardized atmosphere. The reason that we refer to a standardized atmosphere is we need some consistency to predict what our aircraft's performance is going to be. Now, you remember in earlier videos we talked about density, altitude, and aircraft performance. This is the chart, again, 006B, Chapter 1, and it shows us the properties of a standardized atmosphere. We reference the standard atmosphere when we reference performance so that we can make accurate performance calculations. Well, folks, that's about it for the atmosphere. A couple of wrap-up questions. How many layers are in the atmosphere? If you said 4 layers, you are correct. All right, final question. Does the percentage of gases change as I cross those 4 layers? What do you think? Nope, they sure don't. The percentage of gases stays the same as you cross those 4 layers. Well, folks, that is our introduction to the atmosphere. We'll see you for the next one.